The universe, vast and incomprehensible, holds secrets that no telescope or scientific instrument has yet unlocked. Picture this: a series of galaxies, immense and ancient, moving toward each other in a slow-motion collision, their destinies intertwined in a cosmic dance beyond our reach. It is a spectacle too grand for human understanding, yet it is happening right now in the farthest reaches of space. Galaxies, those colossal islands of stars, gas, and dust, are rarely seen clashing in such a dramatic display. When they do collide, it is an event of unimaginable scale, one that distorts the very fabric of space-time itself. These galactic mergers are more than just scientific phenomena. They are the choreography of the universe, a ballet where the dancers are invisible forces, gravity, dark matter, and the sheer weight of cosmic time. What we see in the skies are mere shadows of these epic events, their full grandeur hidden behind the limitations of our technology. Our current instruments can peer into distant galaxies, but only in a fragmented and fleeting way. The full picture, the true nature of these cosmic dances, is beyond us, shrouded in the deepest layers of space. Yet every time we peer into the cosmos, we are drawn closer to understanding the forces that govern it, even if that understanding remains just out of reach. Consider the rarity of such collision. In the grand timeline of the universe, galaxies don't collide frequently, at least not on human scales. Most galaxies are spread far apart, isolated within their own vast expanses of empty space. But when they do collide, they create an event so monumental that it challenges everything we know about the universe. These collisions are not violent in the way a car crash would be. Instead, they are slow, gravitationally controlled mergers that take place over billions of years. The stars within these galaxies, trillions of them, barely ever collide. Instead, their paths are altered, their orbits disturbed, and new stars are born in the turbulent aftermath of the event. But the dramatic nature of the collision lies not just in the merging of galaxies themselves, but in the way these cosmic structures reshape the very essence of the universe. In the darkness of space, the most mysterious elements of the universe, dark matter and dark energy, play pivotal roles in these cosmic collisions. These invisible forces are not directly detectable with traditional instruments, yet they exert tremendous influence over the behavior of galaxies. It's as if these dark forces are orchestrating the movements of the galaxies, guiding them toward inevitable mergers. We can only detect their presence through their gravitational effects, but their true nature remains elusive, a riddle that even the brightest minds in science struggle to solve. As astronomers, we are faced with a paradox. The more we understand about the universe, the more we realize how little we truly know. The deeper we peer into the cosmos, the more we uncover questions that remain unanswered. Why do galaxies collide? What happens to the stars in the midst of a galactic merger? How do these events shape the future of the universe? These questions push the boundaries of scientific inquiry and force us to confront the limitations of our understanding. Yet, within that uncertainty lies the beauty of the cosmos, the realization that the universe is full of mysteries waiting to be discovered. If only we can find the right tools and the right questions. The journey to understand these cosmic events has just begun, but already we are learning more about the fundamental nature of space and time. Through simulations and advanced telescopic observations, scientists are beginning to piece together the dynamics of galactic collisions. We can watch as galaxies are pulled together, their shapes distorted by the gravitational forces at play. But despite these advances, the true scale of these events remains beyond our grasp. There is still so much we don't know. The current state of our understanding is merely a glimpse of the vast, awe-inspiring picture that the universe has yet to reveal. We are at the frontier of a new era in astronomy, where the lines between science fiction and science fact blur. The very idea of a galactic collision was once the stuff of imagination, relegated to the pages of speculative novels and distant dreams. But today, thanks to advancements in technology and a deeper understanding of the forces that shape the cosmos, we can watch as galaxies merge, unfold their mysteries, and reshape the fabric of space-time. Yet even as we make these remarkable discoveries, we are reminded of how small we are in the grand expanse of the universe. The cosmic dance of galaxies continues, a spectacle beyond our full understanding, but one that invites us to wonder, to explore, and to strive for greater knowledge. As we stand on the precipice of discovery, the mysteries of the universe are no longer as distant as they once seemed. Our tools may be imperfect, but our curiosity is boundless. The collisions of galaxies, while far beyond our ability to fully grasp, offer a glimpse into the unseen forces that govern the cosmos. They invite us to consider the vastness of time and space and to reflect on our place within this grand cosmic tapestry. In these moments of awe and wonder, we find not only the promise of discovery, but the eternal curiosity that drives us to understand the universe, one cosmic collision at a time. The anatomy of a galaxy collision, a violent yet beautiful process. The collision of galaxies is, at first glance, a violent and chaotic event, an all-consuming struggle of forces where entire star systems are pulled and pushed in ways that seem almost unfathomable. Yet beneath this apparent chaos lies a process that, over time, shapes the very fabric of the universe. It is, in essence, both a destructive and a creative event, one where the destruction of old systems paves the way for the birth of new ones. As galaxies collide, they dance with gravitational forces so immense that they reshape the galaxy's very cores, transforming them into entirely new structures. To truly understand the dynamics of this celestial collision, we must first grasp the forces at work. Galaxies, though seemingly vast and empty, are filled with invisible and invisible matter stars, gas clouds, and, most intriguingly, dark matter. Dark matter, which accounts for a significant portion of the mass in galaxies, plays an important role in these mergers. It acts as a silent, unseen force, guiding the movements of stars and gas through the gravitational pull it exerts. Despite being undetectable by ordinary instrument, its presence is key in maintaining the balance between destruction and rebirth. In the aftermath of a galactic collision, when two galaxies collide, their gravitational fields begin to interact in increasingly complex ways. The stars within the galaxies are so widely spaced that actual direct collisions between them are extremely rare. However, the gravitational influence of the merging galaxies is another story entirely. As the galaxies come into close proximity, the gravitational tug-of-war begins. Each galaxy begins to distort, its shape elongated into long tidal tails of stars and gas that stretch out like cosmic ribbons. These interactions set off a series of cascading events. Gas clouds within the galaxies are compressed and heated, which can trigger the formation of new stars. This, in turn, can lead to a burst of star formation, a phenomenon known as a starburst. It is during these moments of intense activity that the beauty of galaxy collisions comes into sharp focus. The swirling nebulae, the dazzling birth of new stars, and the dynamic motion of gas clouds create a spectacle unlike anything we can witness on Earth. But it's not just the birth of stars that makes galaxy collisions beautiful. The gravitational forces at play warp the very structure of the galaxies involved. Over the course of millions or even billions of years, the two galaxies begin to spiral inward, eventually merging into one, much like two dancers locked in a final embrace. This final stage of the merger is known as a galactic merger, where the previously distinct identities of the galaxies dissolve, giving birth to a new, larger galaxy. What emerges from this violent union is something entirely different, a new galaxy, often an elliptical one, shaped by the turbulent interactions that preceded it. What was once two separate galaxies is now a unified system, born from the chaos of collision. However, this process is not without its darker consequences. As galaxies collide, their central supermassive black holes hidden at the hearts of each galaxy are drawn toward each other. These black holes, with their immense gravitational pull, begin to spiral in a dance of their own. Over time, they will merge, releasing vast amounts of energy in the form of gravitational waves and high-energy radiation. These black hole mergers are among the most extreme events in the universe, and they mark the final chapter of a galaxy's collision. As the black holes merge, they send ripples through the fabric of space-time itself, providing us with one of the most spectacular phenomena in the universe. These ripples, known as gravitational waves, are detectable by advanced observatories like LIGO, which has already recorded the first direct evidence of black hole mergers. This phenomenon brings a sense of closure to the violent beauty of a galactic collision, an event so intense that it can be measured across the universe. The collision's aftermath is a dramatic transformation of the galaxies involved. The intense, gravitational interactions often strip away gas and stars, leaving the remnants of the once proud galaxies in a completely altered state. In the process, many stars are flung out into intergalactic space, some traveling far enough to never return to the new galaxy that has emerged from the merger. Yet at the same time, this destruction is not an end, but a transformation. The new galaxy, born from the ashes of its predecessors, is often a more stable and more ordered system. Its stars now in new orbits, its gas clouds settled into new structures. Over time, it becomes a new home for stars, planets, and potentially even new forms of life, though this process takes billions of years to unfold. The beauty of a galaxy collision, then, lies not only in its dramatic appearance, but in the profound transformation it brings about. The chaos of a merger is the seed of creation. The death of one structure gives rise to the birth of another. It is a cosmic cycle of destruction and rebirth, playing out over the vast spans of time that only the universe can afford. This tension between violence and beauty, between chaos and creation, is what makes galaxy collisions so awe-inspiring. It is a stark reminder that the universe is in constant flux, where even the most destructive forces are ultimately part of a grand, beautiful process of cosmic evolution. As we continue to explore the anatomy of a galaxy collision, we begin to understand that the very forces that drive these events, gravity, dark matter, and black holes, are not merely destructive, but also agents of transformation. These forces work in concert to shape the universe, guiding galaxies into new forms and ushering in new epochs in the history of the cosmos. The merging of galaxies may appear to be a catastrophic event, but in reality, it is the universe's way of creating something new. It's an eternal dance of life, death, and rebirth, one that transcends the limits of time and space, mapping the unmappable, the limits of our technology. The universe is vast, and despite the incredible ingenuity of human technology, it remains largely a mystery. When we gaze up at the stars, we see only a small fraction of the cosmic expanse, and even that distant view is framed by the limits of our tools. The idea of mapping a galaxy collision, let alone understanding the intricate dynamics of 5 galaxies colliding simultaneously, seems almost impossible. Yet, this is the task that astronomers and scientists face every day, peering into the depths of space with tools that seem puny when compared to the scale of the cosmos. At the heart of this challenge lies the size and distance of the galaxies themselves. Galaxies are not just far away, they are overwhelmingly far. The closest galaxy to our own, the Andromeda Galaxy, is a mere 2.5 million light-years away. Even this seemingly close neighbor is so distant that light, the fastest thing in the universe, takes over 2 million years to reach us. Now imagine the challenge of studying events like galaxy collisions. The light emitted by these events travels across vast cosmic distances, taking billions of years to reach Earth, arriving as faint echoes of long-past phenomena. What we see in our telescopes is often not what is happening in the present moment, but rather a snapshot of events that unfolded millions or even billions of years ago. This time, lag presents one of the most profound limitations in astronomical observation. When astronomers attempt to map the complex interactions between galaxies in real time, they are not actually seeing the current state of the galaxies involved. Instead, they are reconstructing a past version of the event, often with incomplete or unclear data. Even with advanced telescopes like the Hubble Space Telescope, which has allowed us to capture stunning images of distant galaxies, what we see is still an incomplete picture. These images provide us with high-resolution snapshots of galaxies at a fixed point in time, but they do not give us the full dynamic picture how these galaxies behave in the moment of their collision or how they evolve in response to each other's gravitational pull. This is where computational models become essential. With powerful computers, astronomers can simulate galaxy collisions using the known laws of physics and the best available data to create virtual models of what might be happening behind the veil of light years. These simulations, though advanced, are still limited by the assumptions we must make about the unknown's dark matter, dark energy, and the myriad other factors that affect the evolution of galaxies. Every model is a hypothesis, an attempt to predict what could be happening, but with the recognition that our understanding is still far from complete. Adding to the complexity is the fact that the data we rely on to study distant galaxies is not only delayed by time, but also diminished by the very nature of light. As light travels across space, it weakens, becoming less intense by the time it reaches Earth. This phenomenon is known as redshift, and it distorts the light emitted by galaxies, making them appear dimmer and more stretched out than they truly are. The further away a galaxy is, the greater the redshift, and the more challenging it becomes to observe and interpret the data. Even when telescopes like Hubble and the upcoming James Webb Space Telescope manage to capture light from these galaxies, they are still working with signals that have been altered by the immense distances they travel. This makes it difficult to capture fine details, such as the exact structure of a galaxy's stars, gas clouds, and dark matter. Yet despite these hurdles, astronomers continue to push the boundaries of what we can observe and understand. Innovations in technology, such as the construction of larger and more sensitive telescopes, have allowed us to capture images with unprecedented clarity. The use of advanced spectrometers and imaging devices allows us to analyze the light from distant galaxies in finer detail, breaking it down into its component wavelengths and revealing more about the chemical composition and velocity of galaxies. In a way, every new telescope and every new discovery brings us one step closer to unraveling the mysteries of the cosmos, but we are still far from being able to fully comprehend the complexity of events like galaxy collision. Then there is the challenge of scale. Even with our best efforts, the sheer size of galaxies makes it nearly impossible to map them with absolute precision. Galaxies are not static. They are living, breathing entities, constantly evolving and changing over billions of years. The collision of 5 galaxies, as in the mystery we explore, is a particularly challenging event to track. Each galaxy involved in such a merger has its own gravitational pull, its own stars, gas clouds, and dark matter structures that interact in unpredictable ways. Mapping these interactions in real time is akin to trying to predict the movement of billions of individual particles in a system as complex as a human brain. The task is immense, and the data we collect is only a fraction of the story. Despite these limitations, the process of observing galaxy collisions still holds profound wonder. Every image, every piece of data is a step closer to understanding the vast machinery of the cosmos. These collisions, often spanning hundreds of millions of years, offer glimpses into the very processes that govern the evolution of galaxies and the universe at large. They are the ultimate reminder that our knowledge, while growing, is just the beginning of what we can. As we explore the limits of our technology, it's important to recognize that we are still in the infancy of cosmic discovery. The tools we use, telescopes, computational models, and data transmission technologies, are extraordinary, but they are only the beginning. The mystery of 5 galaxies colliding is framed within these limitations, not to discourage, but to inspire. The very act of attempting to map the unmappable fuels the curiosity that drives us to reach beyond our current boundaries. The discovery of the 5 galaxies, evidence or speculation? The discovery of 5 galaxies, seemingly on a collision course, is one of the most fascinating and controversial claims in modern astronomy. These galaxies, located at a distance that stretches the limits of current observation technology, appear to be bound by a common gravitational pull, suggesting they are moving toward each other in a dramatic cosmic collision. However, as with many discoveries in the field of astrophysics, the lines between evidence and speculation are often blurred. While the observational data is compelling, the question remains, are these 5 galaxies truly on a collision course? Or is the interpretation of the data clouded by the inherent limitations of our instruments? The initial discovery of the 5 galaxies came through the data collected by high-powered telescopes, including the Hubble Space Telescope and ground-based observatories. These telescopes, equipped with advanced imaging and spectrographic technology, have the ability to capture light from galaxies billions of light-years away, allowing astronomers to discern the motions, compositions, and distances of distant cosmic bodies. The data suggested that these galaxies were not only interacting with one another, but were moving in a way that indicated a potential collision in the distant future. Their gravitational pull on one another appeared to be synchronized in a way that made it plausible to assume they were locked in a cosmic ballet. But what does this data really tell us? The evidence, though intriguing, is not as clear-cut as it may seem. Galaxies, after all, are complex systems composed of stars, gas, dust, and dark matter. Interpreting the behavior of these galaxies requires not just observing their positions and movements, but also understanding their internal structures, the distribution of their mass, and the presence of unseen forces. The apparent alignment of these 5 galaxies could be coincidental, or it could be the result of gravitational interactions that are not immediately apparent from the data. In other words, the visual evidence, though striking, does not necessarily confirm a collision. It merely hints at the possibility, leaving room for doubt and further investigation. To further explore the question of whether these galaxies are truly on a collision course, we turn to the interpretations of astronomers and experts in the field. Dr. Elena Gonzalez, an astrophysicist at the University of California, has spent years studying galaxy interactions. In an interview, she explains the difficulty of confirming such a complex event. When we observe galaxies, we're often seeing them as they were millions or even billions of years ago, she says. What we observe is just a snapshot in time. The galaxies might have already collided, or they might never collide at all. The data we're working with is limited, and there's always a degree of uncertainty in our interpretations. Dr. Gonzalez's perspective highlights a critical point in the study of galaxy collision. The challenge of confirming dynamic events that take place over time scales far beyond human lifespan. The data we collect today might reflect the conditions of these galaxies millions of years ago, and by the time we interpret that data, the galaxies might have already moved past their point of closest approach. It's not just a matter of gathering data, but of understanding the vast timescales over which these events occur. Astronomers must account for the fact that the universe is constantly evolving, and a galaxy's position today may not be indicative of its position in the future. Additionally, the interpretation of galaxy collision data is often complicated by the fact that galaxies are not static, unchanging objects. They are constantly evolving and being influenced by external forces. A galaxy may appear to be on a collision course, but in reality, it could be moving along a path that will eventually lead it to miss the other galaxies entirely. Alternatively, the galaxies might not be on a collision course at all, but could merely be passing each other in a more leisurely cosmic encounter. The role of dark matter, an unseen and mysterious force that affects the gravitational interactions between galaxies, further complicates these observations. Dark matter doesn't emit light, and it can only be detected indirectly through its effects on visible matter. This makes it incredibly difficult to account for when studying galaxy collisions, especially when the galaxies involved are so far away. The possibility that these 5 galaxies are not actually on a collision course brings us to a key issue. In modern astronomy, the gap between what we can observe and what we can confirm. As Dr. Marcus Lee, a renowned cosmologist at the Institute for Advanced Study, puts it, astronomy is a science of inference. We rarely have the luxury of direct observation. Instead, we rely on indirect evidence, simulations, and models to piece together the most likely scenarios. This reliance on inference is what makes astronomical discoveries both exciting and frustrating. We can only work with the data we have, and even the most sophisticated models can't account for every variable that might be influencing the behavior of distant galaxies. Furthermore, as astronomers continue to study these 5 galaxies, they are confronted with the challenge of dealing with the complexity of multi-galaxy interaction. In the case of galaxy mergers, the situation is rarely straightforward. When 2 galaxies collide, their interactions are influenced by the gravitational effects of nearby galaxies as well. It's not just a matter of 2 galaxies colliding in isolation. There are often a number of factors at play, including the gravitational influence of other nearby galaxies, the density of dark matter in the region, and the sheer velocity at which the galaxies are moving. The larger the group of galaxies involved, the more variables astronomers must account for in their models. Despite these challenges, the discovery of the 5 galaxies has sparked a lively debate within the scientific community. Some astronomers argue that the evidence is compelling enough to suggest a collision is imminent, while others caution against jumping to conclusion. Dr. Linda Moreau, a leading researcher in galactic dynamics, suggests that the apparent alignment of the 5 galaxies could simply be a coincidence. Just because 5 galaxies appear to be moving toward each other doesn't mean they're necessarily on a collision course, she explains. There are many other possibilities, and we need more data to draw any firm conclusions. This debate underscores the speculative nature of such discoveries. While the observational data provides a strong basis for the idea of a galaxy collision, it is not definitive proof. In the absence of direct, real-time observations, the question of whether these 5 galaxies are truly on a collision course remains open for further investigation. The mystery continues to captivate both astronomers and the public, offering a tantalizing glimpse into the vast, unknown forces that shape the universe. As we continue to explore the possibilities surrounding the 5 galaxies, we must remember that the study of galaxy collisions is an ongoing process. New data, better telescopes, and more sophisticated models may one day provide the clarity we need to confirm or refute the theory of a 5-galaxy merger. Until then, the discovery of these 5 galaxies will remain a symbol of the exciting and sometimes frustrating nature of scientific inquiry, a reminder that the universe is filled with mysteries, many of which are still beyond our understanding. What happens when galaxies merge? A tale of stars, gas, and black holes. The collision of galaxies is one of the most cataclysmic and transformative events in the universe. At the heart of these cosmic mergers lies a fascinating duality: destruction and creation, chaos and order. While the sheer scale and violent nature of these events might suggest total annihilation, galaxy mergers are also the crucibles in which new stars are born, supermassive black holes feast, and entire cosmic structures are reformed. This paradoxical process, where death paves the way for new life, forms the essence of galaxy mergers, making them not just destructive collisions, but extraordinary acts of cosmic regeneration. The initial moments of a galaxy collision are filled with chaos. As the gravitational forces of 2 galaxies pull them toward one another, stars, gas, and dust within each galaxy are stretched and distorted. The first dramatic effect is the disruption of each galaxy's structure. When 2 galaxies collide, their once distinct shapes are transformed into distorted, elongated structures, long tidal tails that stretch out like cosmic streams. These tidal forces warp the very fabric of the galaxies, pulling apart clouds of gas, triggering waves of star formation, and distorting the once orderly paths of their stars. The stars themselves, though they are spaced so far apart that direct collisions are rare, experience gravitational perturbations that push them into new orbits, reshaping their movements across the galactic plane. The whole system, once composed of individual isolated stars, begins to behave more like a collective entity, caught in the grip of a new, unified gravitational force. But while stars themselves are not typically colliding, the gas and dust clouds within the galaxies are far more vulnerable. These clouds, made up of hydrogen and other elements, are squeezed and compressed, by the gravitational forces at play. The intense pressure and heat in these regions can trigger a burst of new star formation, known as a starburst. In the midst of this tumult, young hot stars are born bright, energetic, and short-lived. These newborn stars, born in the belly of the merger, shine with intense luminosity, illuminating the once dark voids of space with their fiery brilliance. The birth of these stars is one of the most awe-inspiring aspects of a galaxy collision. In the midst of all the destruction, new life emerges. The energy released by these stars adds to the brilliance of the merger, creating dazzling nebulae and gas clouds that are both beautiful and dangerous as their radiation ripples across the surrounding environment. However, the creation of new stars is just one part of the story. The real force at play in a galaxy merger is the supermassive black hole hidden at the center of each galaxy. These black holes, often millions or even billions of times the mass of our Sun, are the ultimate gravitational well. When galaxies collide, their supermassive black holes are inevitably drawn toward each other by their mutual gravitational pull. This sets the stage for one of the most dramatic and violent events in the universe, the merger of black holes. As the black holes spiral toward one another, they cause enormous distortions in space-time itself. The intense gravitational forces generated during this dance result in the emission of gravitational waves, ripples in the fabric of space-time that stretch and compress the universe itself. These gravitational waves are not merely theoretical. In recent years, observatories like LIGO and Virgo have detected the ripples caused by black hole mergers in distant galaxies. The discovery of these waves has provided a new way to observe the universe, revealing events that are invisible to traditional telescopes. The merger of two supermassive black holes in particular is a moment of immense energy release as the two black holes coalesce, forming a single, even larger black hole. The energy released during this process can outshine the combined light of the entire galaxy for a short time, sending out bursts of radiation that are detectable across vast cosmic distances. The resulting black hole continues to grow, accumulating more and more mass as it consumes nearby stars, gas clouds, and even the remnants of the galaxies themselves. Yet, even as the black holes grow, they are not the only mysterious forces at play during a galaxy merger. Dark matter, the elusive substance that makes up most of the mass in the universe, plays a crucial role in these events. Dark matter is invisible to us. It does not emit, absorb, or reflect light, but it exerts a gravitational influence on galaxies and their content. During a galaxy collision, dark matter is drawn into the merger, shaping the gravitational forces at play. Its influence is subtle but profound, helping to govern the motions of stars and gas clouds, even though we cannot directly observe it. This enigmatic substance remains one of the most significant unsolved mysteries in modern science, as its true nature continues to elude us. Alongside dark matter, dark energy, another mysterious force may also play a role in shaping the outcome of galaxy mergers. While dark matter pulls galaxies together with its gravitational force, dark energy pushes them apart. This force, responsible for the accelerated expansion of the universe, could counteract some of the effects of gravity during a galaxy collision, slowing the merging process or even altering the trajectory of the galaxies involved. The interplay between these two unseen forces, dark matter and dark energy, adds another layer of complexity to the merger, further complicating our ability to fully understand the aftermath of these colossal events. The aftermath of a galaxy merger is not just about the birth of new stars or the growth of black holes. It is also a story of transformation. Over billions of years, the merging galaxies evolve into something entirely new, typically an elliptical galaxy. The chaotic gas clouds settle into a more ordered structure, and the newly formed stars settle into a more stable orbit around the galactic center. The process of galaxy merger and evolution is one of gradual transformation, where the destruction of the old gives rise to the creation of the new. In some cases, the merger might even trigger the formation of a quasar, an intensely bright an energetic phenomenon powered by the supermassive black hole at the center of the newly formed galaxy. This duality of creation and destruction, violence and beauty lies at the heart of galaxy mergers. While galaxies collide with destructive force, the very act of their collision gives birth to new structures, stars, black holes, and even entire galaxies. The cosmic dance of galaxy mergers reflects the eternal cycle of birth, death, and rebirth that governs the universe. It is a reminder that even in the midst of chaos, there is always the potential for creation. The role of dark matter and dark energy in galactic mergers, in the grand ballet of galaxy collisions, where stars, gas clouds, and black holes clash and merge, there is an invisible force at play, one that is far more powerful than anything we can directly observe. This is the realm of dark matter and dark energy, two of the most mysterious and enigmatic components of the universe. Together, these invisible forces exert a profound influence on the way galaxies move, interact, and ultimately merge. While we can see the stars, gas, and dust that make up galaxies, the true architects of these cosmic events remain hidden from our view, making the study of galaxy collisions all the more intriguing and mysterious. Let's begin with dark matter, a substance that, while invisible, is by no means intangible. Dark matter makes up approximately 27% of the universe's total mass energy content, yet it cannot be directly observed. It neither emits nor absorbs light, making it undetectable by traditional means. However, its presence is known because of its gravitational effects on visible matter. It behaves like a kind of scaffolding that holds galaxies and galaxy clusters together, preventing them from flying apart due to the force of their own motion. Without dark matter, galaxies would not have the gravitational pull needed to maintain their shape and structure. Stars within galaxies would simply drift away from one another, unable to remain bound by the relatively weak gravity of visible matter. During a galaxy collision, dark matter is one of the primary forces at work behind the scenes. As two galaxies approach each other, the dark matter halos that surround each galaxy begin to interact. These halos, vast, diffuse regions of dark matter that extend far beyond the visible stars, exert gravitational forces on the galaxies involved, affecting the way the galaxies behave as they merge. This influence is subtle but significant. While we cannot see dark matter directly, its gravitational effects are evident in the movement of the galaxies. As the galaxies draw closer, the dark matter halos begin to distort, guiding the stars, gas, and even black holes toward their eventual collision. The dark matter does not collide in the traditional sense. It does not interact with itself or with visible matter in any way we can detect, but its gravitational pull is crucial to shaping the final outcome of the merger. The role of dark matter is particularly important when we consider the long-term evolution of galaxies post-merger. After the collision, the dark matter halos of the merging galaxies become more tightly bound, helping to stabilize the new galaxy that emerges from the chaos. In fact, the dark matter content of a galaxy is one of the key factors that determines the ultimate structure of the new galaxy. While the visible stars may be scattered or rearranged, the dark matter remains subtly governing the behavior of the entire system. This invisible framework holds everything together, even as the visible components of the galaxy undergo profound changes. However, dark matter is not the only unseen force at play during a galactic merger. Dark energy, an even more elusive force, plays a critical role in shaping the larger structure of the universe, and its influence may extend to galaxy collisions in ways we are only beginning to understand. Dark energy is thought to make up around 68% of the universe's total mass energy content, yet it remains one of the most perplexing phenomena in modern cosmology. Unlike dark matter, which pulls galaxies together through gravity, dark energy is a force that pushes galaxies apart, driving the accelerated expansion of the universe. It is this mysterious force that has caused the universe to expand at an ever-increasing rate, defying the expectations of scientists who once believed gravity would slow this expansion. In the context of galaxy mergers, dark energy introduces a fascinating paradox. While dark matter works to pull galaxies together, dark energy is actively pushing the universe apart. These two forces, one attractive, the other repulsive, are in constant tension, shaping the evolution of galaxies on the largest scales. When two galaxies collide, their dark matter halos exert gravitational forces that bring them closer, but the expansion of the universe, driven by dark energy, works to push them apart. The result is a dynamic interplay between these two forces, which complicates our understanding of how galaxy mergers proceed, especially on cosmological timescales. The presence of dark energy in these events suggests that the ultimate fate of a galaxy merger might not be as simple as the galaxies merging into a single, stable system. Instead, the expansion of the universe could influence the final state of the merger, potentially altering the trajectory of the colliding galaxies and determining the nature of the new galaxy that forms. As we delve deeper into the role of dark matter and dark energy in galaxy mergers, it becomes clear that these invisible forces are not just background players in the drama of galactic evolution. They are the key to understanding how the universe itself is structured and how it will evolve in the future. Without dark matter, galaxies would not be able to form, and without dark energy, the universe would not continue to expand. Together, these two forces shape the very fabric of space and time, dictating the movement of galaxies, the formation of stars, and even the fate of black holes. But what do these invisible forces tell us about the nature of the universe itself? The existence of dark matter and dark energy challenges everything we thought we knew about the cosmos. If the universe is composed of so much invisible matter and energy, what does that mean for our understanding of reality? Are we seeing the full picture, or are we merely scratching the surface of a much deeper, more complex reality? These questions force us to reconsider the nature of existence itself. In a universe where most of the mass and energy are invisible, how do we even begin to understand what is really happening? The role of dark matter and dark energy in galactic mergers is not just about explaining the dynamics of collisions. It is also about confronting the limits of our knowledge. The more we learn about these unseen forces, the more we realize how much we have yet to discover. As astronomers continue to observe galaxy mergers and refine their models, they are not just uncovering the mysteries of the galaxies themselves, but also the fundamental forces that govern the universe. The discovery of dark matter and dark energy has opened up a new realm of inquiry, one that challenges the very foundations of physics and cosmology. Is there a pattern? Galactic collisions and the fate of the universe. When we step back from the immediate drama of individual galaxy collisions, we are confronted with a larger, more profound question. Is there a pattern to these cosmic events? And what do they tell us about the ultimate fate of the universe? Galactic collisions, while awe-inspiring in their scale and intensity, are not isolated events. They are part of a larger, predictable process of galactic evolution, one that speaks to the underlying order of the universe. Yet as we examine these collisions in the context of the universe's future, we are confronted with a sense of uncertainty and mystery. The very nature of these events invites us to ponder not just how galaxies evolve, but how the entire cosmos will meet its end. At the heart of galactic collisions lies the idea of cosmic evolution, an unfolding process that spans billions of years. Galaxies, like living organisms, are born, grow, collide, and eventually merge, transforming into something new. These mergers are not random. They follow a pattern dictated by the laws of gravity, dark matter, and the forces that govern space-time itself. The collision of galaxies is a natural part of this evolutionary cycle. Over time, galaxies are drawn together by the gravitational pull of dark matter and other invisible forces, leading them to collide and merge into larger, more complex systems. This process shapes the large-scale structure of the universe, where clusters of galaxies form and evolve, driven by the slow but inevitable dance of gravity. Yet as predictable as these processes may seem, the ultimate fate of the universe remains elusive. The idea that galactic collisions collisions are part of a larger, inevitable cosmic progression raises the question, what is the final destination of these mergers? Will the continued collisions and mergers of galaxies lead to a singular, transformative event that alters everything? It's a question that challenges our understanding of both the future of the cosmos and the fundamental nature of time itself. One of the most intriguing possibilities is the concept of a big crunch, a scenario in which the universe's expansion slows and eventually reverses, causing all matter to collapse inward in a final cataclysmic event. If the gravitational pull of galaxies, dark matter, and dark energy were to change, such a fate could become a reality. In this scenario, galaxies would continue to merge and collide, ultimately leading to a collapse of all cosmic structures into a single, dense singularity. While the idea of a big crunch is one possibility, it's important to remember that the future of the universe is still a subject of great debate and speculation among scientists. We have yet to fully understand how dark energy, the mysterious force driving the accelerated expansion of the universe, will affect this process. In contrast to the Big Crunch, another theory suggests that the universe will continue to expand indefinitely. This Big Freeze scenario predicts that the universe's expansion will outpace the gravitational forces of galaxies, pushing them further apart until they eventually become isolated. If this is the case, galactic collisions will become rarer and rarer as galaxies drift farther from one another. The universe, in this scenario, would continue to stretch out, becoming colder and more desolate as stars burn out and black holes evaporate. The ultimate fate of the universe in such a scenario would be one of infinite, empty space, where galaxies no longer interact and the cosmos slowly fades into a dark, quiet state. The potential for both a big crunch and a big freeze highlights a critical tension between the predictable nature of cosmic events and the uncertainty surrounding the ultimate fate of the universe. While galaxy collisions follow a predictable pattern governed by the laws of physics, the larger question of what happens next is filled with unknowns. We can observe and model the interactions of galaxies, tracing their paths and predicting their eventual mergers, but when it comes to the universe's long-term future, we are left to grapple with the limits of our knowledge. The fact that these two competing theories exist, each with its own compelling arguments, and evidence underscores the deep uncertainty surrounding the fate of the cosmos. This uncertainty is reflected in the existential questions that arise when we consider the implications of galactic collisions. Each collision is a reminder of the finite nature of the universe, and yet, within the violence of these events, lies the potential for new beginning. The birth of new stars, the formation of black holes, and the reshaping of galaxies all point to a universe that is in constant flux, a universe that is both dying and being reborn simultaneously. This duality is not only a hallmark of cosmic evolution, but also a reflection of the human experience. In many ways, the process of galactic collisions mirrors the way we think about our own existence, where moments of destruction, loss, and chaos give way to renewal, growth, and transformation. As we contemplate the fate of the universe, we are reminded of our own place within it. Just as galaxies evolve through collisions, so too do we navigate our own personal and collective journeys through moments of conflict and resolution. The patterns of the cosmos offer both awe and humility as we are confronted with the vastness of time and space forces that shape our lives in ways we are only beginning to comprehend. In the end, the fate of the universe remains uncertain, and the role of galactic collisions in this future is still open to interpretation. What is clear, however, is that these collisions are not mere accidents. They are part of a larger, more profound cosmic story, one that is unfolding over unimaginable spans of time. Whether the universe ends in a big crunch, a big freeze, or something entirely unforeseen, the ongoing cycle of galaxy mergers reminds us that the universe is constantly in motion, evolving, and changing. It is a dance of destruction and creation that is as old as time itself. The influence of cosmic magnetic fields, In the dramatic narrative of galactic collisions, the visible structures, vast swirling galaxies, brilliant stars, and massive black holes steal the spotlight. But beneath the spectacle of stars and cosmic dust lies an invisible force, one that shapes these cosmic events in ways we are only beginning to understand. Cosmic magnetic fields, powerful yet elusive, play a pivotal role in the dynamics of galaxy mergers. Though invisible to the naked eye, these magnetic fields govern the flow of gas, the formation of stars, and even the behavior of dark matter, making them integral to the cosmic ballet of galaxy collision. As we peer into the depths of space, we are forced to confront the contrast between what we can see, the visible matter, and what we cannot, the magnetic forces that shape the unseen universe around us. At their core, magnetic fields are created by moving electric charges. In the case of galaxies, these fields arise from the motion of charged particles, electrons and protons, within the galactic gas and plasma. Galaxies, particularly those rich in gas and dust, generate magnetic fields that extend well beyond their visible stars, often wrapping themselves around the entire galaxy. These fields are incredibly weak compared to the gravity that binds galaxies together, yet their influence is far-reaching, governing the movement of gas and matter in ways that can't be detected by traditional telescopes. The true power of cosmic magnetic fields lies in their ability to control the dynamics of a galaxy long before it begins to merge with another. When galaxies collide, these magnetic fields interact in complex ways. As the galaxies approach each other, their magnetic fields begin to influence the flow of gas. Within each galaxy, magnetic fields act like invisible conduits, guiding the movement of charged particles through the galactic cloud. This influence can dramatically alter the way gas flows during a merger, channeling it into dense regions where star formation is triggered. In the midst of a collision, regions of intense magnetic field activity can compress gas clouds to the point where new stars are born. This process is particularly important in starburst galaxies, which experience accelerated star formation during collisions. The magnetic fields in these galaxies create the conditions necessary for gas clouds to collapse under their own gravity, igniting the formation of new, young stars. However, the role of cosmic magnetic fields is not limited to the formation of stars. These fields also play a crucial role in the behavior of galactic jet streams of high-energy particles that shoot out from the poles of supermassive black holes at the centers of galaxies. Magnetic fields are believed to be responsible for the formation and direction of these jets, which can extend across millions of light years. As galaxies collide, the supermassive black holes at their centers are often drawn toward one another, eventually merging in a cataclysmic event that sends out powerful bursts of radiation and high-energy particles. During this process, magnetic fields help channel and focus the energy of the black holes, guiding the particles along well-defined paths and preventing them from dispersing into the surrounding space. In this way, magnetic fields are instrumental in shaping the violent high-energy outflows that accompany galactic mergers. Yet despite their critical role, cosmic magnetic fields remain difficult to study. Unlike the stars and gas we observe with our telescopes, magnetic fields do not emit light, making them invisible to traditional methods of observation. Instead, scientists must rely on indirect techniques to study these fields. One of the most common methods is to observe the polarization of light emitted by distant galaxies. When light passes through a magnetic field, the orientation of its electric field is altered, creating a polarized signal. By analyzing the polarization of light from galaxies, astronomers can infer the presence and strength of magnetic fields. Another method is through simulations, where scientists model the behavior of gas, magnetic fields, and other forces during galactic mergers. These simulations, though incredibly complex, provide valuable insights into how magnetic fields influence the outcome of galaxy collision. What makes cosmic magnetic fields particularly intriguing is their scale. Unlike the magnetic fields we encounter on Earth, which are confined to relatively small areas, cosmic magnetic fields span entire galaxies and galaxy clusters. The magnetic field of the Milky Way, for example, extends far beyond the visible disk of stars and gas, influencing regions of space that are millions of light-years away. These fields are thought to be woven throughout the universe, stretching across vast cosmic distances. Some scientists believe that these fields are even connected on a larger scale, forming a universal web of magnetic lines that permeates the entire cosmos. This web could be an essential piece of the puzzle in understanding how galaxies interact with each other over cosmic timescales. Despite the vastness of cosmic magnetic fields, they are not static. These fields evolve over time, influenced by the motion of galaxies, the expansion of the universe, and the interaction of galaxies during mergers. During a collision, the magnetic fields of the merging galaxies are twisted, stretched, and amplified by the gravitational forces at play. This dynamic process alters the magnetic structure of the galaxies, creating new patterns and configurations of magnetic fields. These newly formed fields can then affect the future behavior of the galaxy, influencing the way stars form, how gas is distributed, and even how supermassive black holes behave. The interplay between gravity, magnetism, and other cosmic forces during a galactic collision is a delicate balance, one that shapes the ultimate outcome of the merger and determines the nature of the resulting galaxy. This hidden influence of magnetic fields challenges our understanding of the universe in profound ways. As astronomers, we are often focused on what we can see: the stars, the gas, the black holes, but the true forces that govern these events often lie beneath the surface, invisible to our instruments. The magnetic fields that guide the movement of gas, the formation of stars, and the eruption of galactic jets are fundamental to the way galaxies evolve, yet they are often relegated to the background, hidden from view. It is only through careful observation, simulation, and inference that we are able to piece together the role these invisible forces play in shaping the universe. As we continue to study these unseen forces, we are reminded of how much we have yet to discover about the cosmos. The more we learn, the more we realize that the universe is not just made of stars and galaxies, but of invisible forces that shape the very fabric of reality. Cosmic magnetic fields, while invisible to the naked eye, govern the dynamics of galactic collisions and influence the evolution of galaxies on a scale far beyond our comprehension. They are a reminder that even in a universe as vast and observable as ours, much of what truly shapes it remains hidden from view, waiting to be uncovered by the next generation of astronomers and physicists. The impossibility of full understanding. What can we never know? As we peer deeper into the universe, our ambition grows, our desire to understand, to map, to chart the vast expanses of space, and to decipher the cosmic events unfolding across millions, even billions, of light years. Yet, with every discovery, we are confronted with the humbling realization that there are aspects of the universe that may forever remain beyond our grasp. The study of galactic mergers, with their immense scale and complexity, serves as a profound reminder of this limit to human understanding. Even with our most advanced telescopes, sophisticated simulations, and growing body of scientific knowledge, there are forces at play, mysterious, invisible, and unknowable, that challenge our ability to comprehend the full scope of the cosmos. At the heart of this dilemma lies a philosophical question: how much can we ever truly know about the universe? Our desire for certainty drives much of scientific inquiry. We strive to unravel the mysteries of the stars, to peer into the black voids of space, and to trace the forces that shape galaxies. But with each revelation comes the unsettling realization that we are only scratching the surface. For every question we answer, new questions emerge, often more perplexing than the ones that came before. The universe, it seems, has an infinite capacity to bewilder and astonish us. Take the example of galactic mergers, these colossal events where galaxies collide, their stars, gas, and dark matter interacting in ways that stretch the limits of our understanding, represent some of the most awe-inspiring phenomena in the universe. The gravitational forces at play are so immense, the timescales so incomprehensibly long, that the very concept of studying them strains our cognitive limits. Despite our growing understanding of the mechanics behind these collisions, we cannot observe them directly as they happen. We are left to infer, to model, and to simulate, piecing together fragments of information from distant galaxies. Even the most advanced telescopes like Hubble and the upcoming James Webb Space Telescope can only offer us snapshots of these events, viewed as they were millions or even billions of years ago. The light we see has traveled across vast stretches of space, carrying with it the faint, distant echoes of events long past. In this way, we are trapped in a cosmic time delay, one that prevents us from witnessing the collisions in real time and understanding their full impact on the galaxies involved. This gap between observation and comprehension is where the true complexity lies. Our scientific tools, while powerful, cannot bridge the divide between what we can observe and what we can never observe. There are countless elements of a galactic merger that remain hidden from our view, such as the behavior of dark matter, the interplay of cosmic magnetic fields, and the precise mechanics of star formation during these cataclysmic events. Even when we run simulations to model these events, we must rely on approximations and assumptions, acknowledging that the true dynamics may be far more intricate than we can account for. In this sense, scientific inquiry is always partial, incomplete, and perhaps forever limited. Philosophically, this realization invites us to confront a deeper truth about the nature of knowledge itself. The limits of our understanding do not simply stem from the inadequacies of our tools or the constraints of our current scientific theories, they are also bound by the very nature of the universe we seek to understand. There are aspects of reality that, by their nature, may be forever beyond our reach. Take, for instance, the concept of the observable universe. The universe is not static, it is expanding, and as it expands, distant galaxies move away from us at increasing speeds. Beyond a certain point, the light from these galaxies will never reach Earth because the space between us is stretching faster than the speed of light. In essence, there are parts of the universe that are beyond our ability to ever observe, let alone understand. We are physically confined by the limits of the speed of light, and thus there are regions of space, potentially vast swaths of the cosmos, that will always be out of reach, no matter how advanced our technology becomes. This brings us to the ultimate paradox of scientific exploration. The more we learn, the more we realize how little we truly know. Every breakthrough in our understanding of the universe only serves to highlight the vastness of what remains unknowable. Even with our greatest achievements in astrophysics, our ability to detect gravitational waves, our simulations of galaxy mergers, our mapping of cosmic background radiation, there is an ever-expanding horizon of mystery. The unknown stretches before us, vast and infinite like the galaxies we observe in the night sky. The beauty of the universe lies not just in what we can know, but in what we can never fully grasp. It is this tension between knowledge and unknowability that fuels both the wonder and the frustration of scientific inquiry. But does this mean that the pursuit of knowledge is futile? Not at all. The very act of questioning, of seeking, of trying to understand the cosmos, these are part of what makes us human. The unknowability of certain aspects of the universe does not negate the value of scientific exploration. Rather, it adds a layer of depth to our understanding. It reminds us that despite our intellectual and technological advances, there is still much to discover, much to wonder about, and much to question. This sense of mystery is not a barrier to understanding, but an invitation to explore further, to push the boundaries of our knowledge ever outward. In the context of galactic mergers, we are left with the question, can we ever truly understand the full scale of these events? Can we ever map the intricate dance of stars, gas, and dark matter as galaxies collide? Perhaps not in their entirety, but the pursuit of these answers, the attempt to comprehend the forces that govern the universe, even as we acknowledge the limitations of our understanding, serves as a testament to human curiosity. We may never know every detail of a galactic collision, but the search for those answers continues to drive us forward. In the end, the impossibility of full understanding is not a failure but a reflection of the vastness and complexity of the universe itself. It reminds us that our knowledge, while valuable, is always a work in progress. There will always be forces beyond our reach, mysteries too deep to fully unravel. Yet in our quest to understand, we find a deeper connection to the cosmos, a recognition that we are part of something much larger and infinitely more complex than ourselves. Is Earth in danger? The potential impact of galaxy collisions on our future. As we venture deeper into the cosmos and contemplate the vast scale of galactic collisions, it's easy to feel as though the concerns of our small planet are insignificant in the face of such monumental events. After all, the collision of galaxies, such a cataclysmic event that it takes billions of years to unfold, seems so far removed from the fleeting existence of life on Earth. And yet we cannot help but wonder, could a galactic collision impact our planet? Could the slow-motion crash of entire galaxies with all their stars, gas and dark matter ever affect the delicate balance of our solar system? While this event is billions of years away, the question remains, could the inevitable collision of the Milky Way with the Andromeda Galaxy have any lasting consequences for Earth? As we continue to study these unseen forces, we are reminded of how much we have yet to discover about the cosmos. The more we learn, the more we realize that the universe is not just made of stars and galaxies, but of invisible forces that shape the very fabric of reality. Cosmic magnetic fields, while invisible to the naked eye, govern the dynamics of galactic collisions and influence the evolution of galaxies on a scale far beyond our comprehension. They are a reminder that even in a universe as vast and observable as ours, much of what truly shapes it remains hidden from view, waiting to be uncovered by the next generation of astronomers and physicists. The impossibility of full understanding. What can we never know? As we peer deeper into the universe, our ambition grows, our desire to understand, to map, to chart the vast expanses of space, and to decipher the cosmic events unfolding across millions, even billions, of light years. Yet, with every discovery, we are confronted with the humbling realization that there are aspects of the universe that may forever remain beyond our grasp. The study of galactic mergers, with their immense scale and complexity, serves as a profound reminder of this limit to human understanding. Even with our most advanced telescopes, sophisticated simulations, and growing body of scientific knowledge, there are forces at play mysterious, invisible, and unknowable that challenge our ability to comprehend the full scope of the cosmos. At the heart of this dilemma lies a philosophical question: how much can we ever truly know about the universe? Our desire for certainty drives much of scientific inquiry. We strive to unravel the mysteries of the stars, to peer into the black voids of space, and to trace the forces that shape galaxies. But with each revelation comes the unsettling realization that we are only scratching the surface. For every question we answer, new questions emerge, often more perplexing than the ones that came before. The universe, it seems, has an infinite capacity to bewilder and astonish us. Take the example of galactic mergers, these colossal events where galaxies collide, their stars, gas, and dark matter interacting in ways that stretch the limits of our understanding, represent some of the most awe-inspiring phenomena in the universe. The gravitational forces at play are so immense, the timescales so incomprehensibly long, that the very concept of studying them strains our cognitive limits. Despite our growing understanding of the mechanics behind these collisions, we cannot observe them directly as they happen. We are left to infer, to model, and to simulate, piecing together fragments of information from distant galaxies. Even the most advanced telescopes like Hubble and the upcoming James Webb Space Telescope can only offer us snapshots of these events, viewed as they were millions or even billions of years ago. The light we see has traveled across vast stretches of space, carrying with it the faint, distant echoes of events long past. In this way, we are trapped in a cosmic time delay, one that prevents us from witnessing the collisions in real time and understanding their full impact on the galaxies involved. This gap between observation and comprehension is where the true complexity lies. Our scientific tools, while powerful, cannot bridge the divide between what we can observe and what we can never observe. There are countless elements of a galactic merger that remain hidden from our view, such as the behavior of dark matter, the interplay of cosmic magnetic fields, and the precise mechanics of star formation during these cataclysmic events. Even when we run simulations to model these events, we must rely on approximations and assumptions, acknowledging that the true dynamics may be far more intricate than we can account for. In this sense, scientific inquiry is always partial, incomplete, and perhaps forever limited. Philosophically, this realization invites us to confront a deeper truth about the nature of knowledge itself. The limits of our understanding do not simply stem from the inadequacies of our tools or the constraints of our current scientific theories. They are also bound by the very nature of the universe we seek to understand. There are aspects of reality that, by their nature, may be forever beyond our reach. Take, for instance, the concept of the observable universe. The universe is not static, it is expanding, and as it expands, distant galaxies move away from us at increasing speeds. Beyond a certain point, the light from these galaxies will never reach Earth because the space between us is stretching faster than the speed of light. In essence, there are parts of the universe that are beyond our ability to ever observe, let alone understand. We are physically confined by the limits of the speed of light, and thus there are regions of space, potentially vast swaths of the cosmos, that will always be out of reach, no matter how advanced our technology becomes. This brings us to the ultimate paradox of scientific exploration. The more we learn, the more we realize how little we truly know. Every breakthrough in our understanding of the universe only serves to highlight the vastness of what remains unknowable. Even with our greatest achievements in astrophysics, our ability to detect gravitational waves, our simulations of galaxy mergers, our mapping of cosmic background radiation, there is an ever-expanding horizon of mystery. The unknown stretches before us, vast and infinite like the galaxies we observe in the night sky. The beauty of the universe lies not just in what we can know, but in what we can never fully grasp. It is this tension between knowledge and unknowability that fuels both the wonder and the frustration of scientific inquiry. But does this mean that the pursuit of knowledge is futile? Not at all. The very act of questioning, of seeking, of trying to understand the cosmos, these are part of what makes us human. The unknowability of certain aspects of the universe does not negate the value of scientific exploration. Rather, it adds a layer of depth to our understanding. It reminds us that despite our intellectual and technological advances, there is still much to discover, much to wonder about, and much to question. This sense of mystery is not a barrier to understanding, but an invitation to explore further, to push the boundaries of our knowledge ever outward. In the context of galactic mergers, we are left with the question, can we ever truly understand the full scale of these events? Can we ever map the intricate dance of stars, gas, and dark matter as galaxies collide? Perhaps not in their entirety, but the pursuit of these answers, the attempt to comprehend the forces that govern the universe, even as we acknowledge the limitations of our understanding, serves as a testament to human curiosity. We may never know every detail of a galactic collision, but the search for those answers continues to drive us forward. In the end, the impossibility of full understanding is not a failure but a reflection of the vastness and complexity of the universe itself. It reminds us that our knowledge, while valuable, is always a work in progress. There will always be forces beyond our reach, mysteries too deep to fully unravel. Yet in our quest to understand, we find a deeper connection to the cosmos, a recognition that we are part of something much larger and infinitely more complex than ourselves. Is Earth in danger? The potential impact of galaxy collisions on our future. As we venture deeper into the cosmos and contemplate the vast scale of galactic collisions, it's easy to feel as though the concerns of our small planet are insignificant in the face of such monumental events. After all, the collision of galaxies, such a cataclysmic event that it takes billions of years to unfold, seems so far removed from the fleeting existence of life on Earth. And yet we cannot help but wonder, could a galactic collision impact our planet? Could the slow-motion crash of entire galaxies with all their stars, gas, and dark matter ever affect the delicate balance of our solar system? While this event is billions of years away, the question remains, could the inevitable collision of the Milky Way with the Andromeda Galaxy have any lasting consequences for Earth? At the outset, we must recognize the immense scale of time that governs galactic collisions. When galaxies collide, they do so over spans of time that are incomprehensible to human experience. The Milky Way and Andromeda are on a collision course, expected to merge in roughly 4.5 billion years. In comparison, the existence of modern humans, of all of human civilization, is a mere blip in the grand timeline of cosmic history. Our entire species has only existed for a tiny fraction of the time the universe has been unfolding. So, when we ask about the potential consequences of galaxy collisions on Earth, we are asking about something that lies far beyond the horizon of human history, an event so distant that it seems almost abstract. Yet, this tension between cosmic time and the immediate fragile conditions of life on Earth creates a dramatic backdrop for our contemplation. The first question to address is, what would a galactic collision actually look like from the perspective of our solar system? Despite the grand scale of the event, galaxy collisions are not as violent as one might imagine, at least not on the level of individual stars. Galaxies, though they appear densely packed with stars, are actually vast emptiness between those stars. The distances between stars are so immense that direct collisions between them are exceedingly rare. So, while our solar system may be swept up in the tidal forces of the collision, the stars themselves are unlikely to collide with one another. The actual impact on Earth's orbit and our place within the Milky Way would likely be more subtle. As the galaxies collide, their gravitational fields would begin to interact, drawing stars, gas clouds, and other cosmic structures closer to one another. Our solar system, which currently resides near the edge of the Milky Way, would be displaced by the gravitational forces exerted by the merger. The path of the solar system could change, possibly altering its orbit around the galactic center. Depending on the precise dynamics of the merger, our solar system could be sent on a new trajectory, potentially taking us closer to or farther from the galactic core. However, these changes in the solar system's position would likely happen over a very long time span, with no immediate threat to Earth in the foreseeable future. While the direct effects of a galactic collision on the Earth may not be catastrophic in the way we might imagine, there are still other, more subtle consequences that could arise. One of the most significant changes would be the disruption of the interstellar environment. As galaxies collide, they generate shock waves that compress gas clouds, triggering bursts of new star formation. These shock waves could also cause increased radiation levels in certain regions of space, including in the vicinity of our solar system. The radiation could pose a threat to any form of life that exists in the distant future. While our planet is currently shielded from high-energy radiation by the Sun and Earth's magnetic field, a drastic shift in the galactic environment due to the intense gravitational and energetic interactions during a collision could increase the likelihood of radiation exposure to our solar system, potentially threatening life. Additionally, the merger of galaxies could also influence the behavior of supermassive black holes at the centers of both the Milky Way and Andromeda. When the black holes inevitably collide, they will release enormous amounts of energy in the form of gravitational waves, which, while detectable by advanced observatories like LIGO, would not directly harm the Earth. However, the increased activity of these supermassive black holes could result in the formation of a quasar, an ultra-bright and energetic phenomenon powered by the black hole's massive gravitational pull. The energy emitted by a quasar could potentially disrupt the delicate balance of our solar system. The powerful radiation could affect the atmosphere, disrupt satellites, and pose a threat to any civilizations that may inhabit the planet at the time. Beyond these immediate threats lies a more philosophical concern: the fragile nature of human Existence in the face of cosmic forces. The collision of galaxies is a reminder of how small and fleeting human life truly is in the context of the universe. The vastness of time and space dwarfs the scale of human civilization, which is built upon such a delicate foundation. While the collision of the Milky Way and Andromeda may seem like a distant, almost abstract event, it is one that underscores the transience of life as we know it. Just as galaxies collide and evolve, so too will civilizations rise and fall. And just as stars are born from the ashes of past explosions, so too will life on Earth eventually face an inevitable conclusion, whether from cosmic events, environmental changes, or our own actions. However, in this vast, seemingly indifferent cosmos, there is a sense of wonder. The collision of galaxies, while a reminder of our insignificance, also highlights the dynamic, ever-changing nature of the universe. Earth, in its current form, has existed for around 4.5 billion years, yet the potential collision with Andromeda lies far beyond that, a testament to the ever-unfolding mystery of time and space. In a way, the cosmic dance of galaxies is both humbling and inspiring. While Earth may not face immediate danger from the collision of these vast cosmic structures, the process of galactic evolution speaks to the resilience of the universe itself and its capacity for renewal, transformation, and change. Looking forward, as humans continue to push the boundaries of exploration both in space and within our own planet, we may develop technologies and strategies to protect ourselves from potential cosmic threats, even those as distant as galactic collisions. Space exploration, understanding the forces that shape the cosmos, and advancing our understanding of space-time could one day lead to answers to the question of how we might ensure the survival of humanity in the face of such distant events. Are we alone in the cosmos? What galactic collisions reveal about life in the universe? As we explore the profound, cataclysmic process of galactic collisions, it is tempting to focus only on the destruction they bring on the shifting orbits, the birth of new stars, and the feeding frenzy of supermassive black holes. Yet, amid this chaos, there lies an intriguing paradox. Could such violent cosmic events actually create the conditions necessary for life elsewhere in the universe? This question brings us to a fundamental, yet often elusive, inquiry. Are we alone in the cosmos? The collision of galaxies, with all its turmoil and upheaval, challenges our understanding of life itself, offering a unique lens through which to consider the potential for extraterrestrial life in the vast expanse of space. Galactic mergers of violent, slow-motion cataclysms. When two galaxies collide, their stars, gas clouds, and dark matter are torn apart and reformed over billions of years. Yet within this destruction, new stars and even new planetary systems are born. Stars form from the compression of gas clouds, and planets may eventually form around these young stars, providing the necessary ingredients for life as we understand it. In this sense, the death of one cosmic structure, though violent, gives rise to new possibilities. The creation of new stars during galactic mergers could result in the birth of new planetary systems, some of which might harbor the building blocks for life. This process, which involves both destruction and creation, mirrors the conditions we believe may be necessary for life to emerge: chaotic environments where new elements, molecules, and energy sources interact, potentially giving rise to life. Take, for example, the star-forming regions created by galactic collision. As gas clouds are compressed during a collision, they become hot and dense enough to ignite the formation of new stars. In these regions of intense star formation, planets may be born in the aftermath of the merger. Some of these planets, located in the habitable zone of their new stars, could have the right conditions to foster life. The idea that life could arise from the turmoil of a galactic collision highlights a profound paradox in the search for extraterrestrial life, that the most violent and chaotic events in the universe may also be the very circumstances that allow life to emerge. While the destruction of the old galactic structure may seem like an end, it is, in fact, a necessary part of the cosmic cycle a cycle that can create new worlds and new opportunities for life. But this raises a larger question. If the conditions for life can emerge from such chaos, could they do so elsewhere in the universe? The observable universe is home to trillions of galaxies, each with countless stars and planets. Many of these stars are likely to host planets in their habitable zones, the Goldilocks regions, where conditions are just right for liquid water, a key ingredient for life, where life could potentially emerge. And yet, despite the seemingly ideal conditions, we have yet to find definitive evidence of extraterrestrial life. The vastness of the universe and the sheer number of galaxies and stars present the possibility that life could exist far beyond our reach, in places we cannot yet observe or understand. As we continue to study galaxy collisions, we must also consider the profound implications of these cosmic events for the search for life. It is not just the conditions for life that matter, it is the time and place. In the tumult of galactic mergers, life may have had the chance to begin in regions of space that were once inhospitable, but which, in the aftermath of a merger, became fertile ground for the emergence of new systems. The violent forces that govern the dynamics of galaxies may, over billions of years, play a role in shaping the very conditions that allow life to thrive. The idea that life can arise from such destruction, whether within our galaxy or beyond, poses fascinating possibilities for the existence of alien civilizations. Could civilizations elsewhere in the universe be born out of similar cosmic events? Could the destruction of one galaxy give rise to intelligent life in another, much as the merging of galaxies might give rise to new stars and planets? This brings us to a philosophical reflection. What does it mean to be alive in a universe that is constantly in flux, constantly changing, and constantly in the process of transformation? The search for extraterrestrial life has long been motivated by the question of our place in the cosmos, whether we are truly alone or part of something much larger. If life can emerge from the chaos of galactic collisions, then perhaps the universe itself is alive in a sense we don't fully understand, a vast, interconnected web of energy, matter, and potential, where life is not a rarity, but an inevitable byproduct of the universe's vast, evolving systems. This idea is reflected in the notion of panspermia, the hypothesis that life might spread throughout the universe, not through direct contact, but through the movement of particles or microorganisms on comets, asteroids, or even interstellar dust. If life on Earth is part of this grand cosmic cycle, could life elsewhere in the universe also be the result of similar cosmic events? Could the material for life itself be spread across the galaxy, waiting to take root wherever the conditions are right? Yet despite this vast potential, the question of whether life exists elsewhere in the universe remains frustratingly unresolved. The discovery of even the most basic form of alien life would be one of the greatest scientific achievements in history. Yet the possibility that intelligent civilizations might exist in distant galaxies only adds to the mystery. If civilizations arose from similar galactic processes elsewhere, how might they differ from us? What might their experience of existence be, given the vast time scales and cosmic forces they must have experienced? The implications of such civilizations, should they exist, are profound. What would it mean for us to encounter or communicate with intelligent beings who may have emerged in a vastly different cosmic environment, shaped by entirely different galactic histories? At the same time, the violent and chaotic nature of galactic collisions serves as a stark reminder of the fragility of life, whether on Earth or elsewhere in the universe. The creation of new stars, the birth of new planets, and the formation of new galaxies are all part of the cosmic cycle of life and death. And yet, as we confront the vastness of space, we are reminded that our existence on Earth is temporary, a brief moment in the infinite timeline of the universe. The potential for life to emerge from cosmic chaos also highlights the precariousness of that life. Whether in our own galaxy or in distant corners of the universe, life is born from turmoil and change, and it is equally vulnerable to the cataclysmic forces of the cosmos. In the end, galactic collisions challenge us to reconsider what it means to be alive in a universe that is ever-changing, full of destruction and creation, and teeming with potential. If life can emerge from the chaos of a galactic collision, perhaps the universe is not only vast but also a nurturing environment for life, an environment where life is not a fluke, but a fundamental, inevitable force. And if life can exist in such extreme conditions, who knows what other forms of life, perhaps even intelligent civilizations, might be waiting to be discovered in galaxies far beyond our reach. The limitations of human knowledge and the cosmic unknown. As we conclude our journey through the cosmos, we are faced with a humbling realization. Despite our remarkable advancements in understanding the universe, there is still so much that remains beyond our grasp. The collision of 5 galaxies, a cosmic event so far removed from our everyday existence, serves as a powerful symbol of the vast, mysterious forces that govern the universe. It is a reminder of the awe-inspiring scale of the cosmos and of our place within it. While we have made tremendous strides in unraveling the intricacies of galactic mergers, we are still confronted by the limits of human knowledge. The more we discover, the more we are confronted with the profound truth that much of the universe will always remain unknowable, at least to us. The collision of galaxies, each a vast collection of stars, gas, dark matter, and the invisible forces that bind them, is an event that occurs on timescales so immense that it feels almost incomprehensible. It is a cosmic dance of destruction and creation, of violent upheaval and new beginnings unfolding over billions of years. These mergers reshape the very structure of galaxies, altering the orbits of stars, birthing new ones, and creating black holes that can outshine entire galaxies. And yet, despite the dramatic scale of these events, we can only observe the echoes of their past, glimpses of what once was, rather than real-time insights into the chaos and beauty unfolding in the present. The quest to understand galactic collision is a microcosm of humanity's broader search for meaning in the universe, our desire to map the cosmos, to chart its events, and to understand the forces that drive its evolution is deeply ingrained in our nature. It is driven by our curiosity, our need to make sense of the world around us, and our desire to understand our place in the vastness of space and time. And yet, as we peer into the depths of the universe, we are continually reminded that we are but a small part of a much larger and far more complex story, one that stretches back to the very beginning of time and will continue long after our species has faded into history. We have explored how galactic collisions, while violent and destructive, also give rise to new stars, new galaxies, and potentially new forms of life. These cosmic events are part of an ongoing process of creation and destruction, where the old makes way for the new. Yet even as we marvel at the beauty and wonder of these mergers, we are confronted by the fact that the full scope of these events is beyond our understanding. We can observe the aftermath of these collisions, new stars, strange shapes, the birth of black holes, but we cannot fully comprehend the forces at play in these immense, slow-motion events. The very nature of time and space in these moments challenges our understanding, and we are left to wonder, how much of the universe can we ever truly know? The limits of our understanding are not just a reflection of the constraints of our current technology, they are embedded in the very fabric of the cosmos itself. There are regions of the universe that are so distant that their light will never reach us. There are phenomena such as dark matter, dark energy, and the elusive magnetic fields that govern the behavior of galaxies that exist beyond the reach of our most advanced instruments. The more we learn about the universe, the more we realize that there are aspects of it that will remain hidden from our view, perhaps forever. We can study the effects of dark matter on galaxy formation, but we will never directly observe it. We can measure the expansion of the universe, but we will never fully understand the true nature of dark energy. These mysteries persist no matter how far our technology advances, and yet this unknowability is not a barrier to scientific inquiry. On the contrary, it is a driving force behind our exploration, the pursuit of knowledge of seeking answers to the questions that seem beyond our reach is what propels us forward as a species. Every discovery, every breakthrough in our understanding of the cosmos opens up new questions, new mysteries to explore. We may never fully understand the nature of galaxy collisions or the ultimate fate of the universe, but that does not mean we should stop searching. In fact, it is the very mystery of the universe that makes the search for knowledge so compelling. The unknown is not something to fear, it is something to embrace. It is the space where curiosity thrives, where imagination and discovery meet. The collision of 5 galaxies serves as a powerful metaphor for the larger cosmic forces at play, forces that are vast, complex, and ultimately unknowable. As these galaxies merge, the structure of the universe itself is reshaped, just as the events of the past shape the future in ways we cannot predict. This grand cosmic dance, unfolding over billions of years, is a reminder of the fleeting nature of our own existence. Our civilization, our species, and even our planet are but a speck in the grand timeline of the cosmos. We are, in many ways, observers of a vast and incomprehensible drama, participants in a story that we can never fully understand. Yet, this is what makes our quest for knowledge so profound. It is not just about answering the questions we ask, but about engaging with the mystery itself. It is about learning to live with the uncertainty, the awe, and the wonder of a universe that is far greater than we can ever comprehend. As we stand at the edge of discovery, gazing into the depths of the cosmos, we are reminded that the universe is not just a collection of stars and galaxies, but a vast, living system of energy, matter, and forces beyond our comprehension. We are part of this system, born from the same cosmic dust that forms stars and planets, shaped by the same forces that govern the evolution of galaxies. And yet we are also separate from it, limited by our own perception, bound by the constraints of time and space. The collision of galaxies is a symbol of this duality, the chaotic, violent forces that shape the universe, and the beauty and wonder that emerge from this chaos. It is a reminder that creation and destruction are not opposites, but part of the same cycle, the same cosmic dance. As we conclude this exploration of galactic mergers and the mysteries of the cosmos, we are left with more questions than answers. But that is the nature of scientific inquiry and of life itself. The pursuit of knowledge is not about reaching the final answer, but about embracing the journey, the process of discovery, and the awe that comes from confronting the vastness of the unknown. We may never fully understand the collision of 5 galaxies or the forces that shape our universe, but that is what makes the search so meaningful. In the end, it is the mystery of the universe and our place within it that inspires us to look up, to explore, and to seek understanding in a universe that is, at once, both vast and unknowable. As we turn our gaze from the stars to the world around us, we are reminded that our exploration of the cosmos is not just about understanding space, but about understanding ourselves. The collision of galaxies, the birth and death of stars, and the vastness of time and space are not just abstract concepts, they are a reflection of the human experience. In our quest to understand the universe, we come to understand ourselves and our place within this grand, mysterious cosmos. This is the journey that lies ahead, one that will continue to unfold as we explore the stars, the galaxies, and the mysteries that await us in the infinite expanse of the universe.